Welcome back to our second three-dimensional structure drawing video. Here I'm going to do three organic molecules. The thing about organic molecules is they tend to chain up, and in doing so we have it's not complex, but you have to keep a couple things in mind, all right? And it's also the reason why we draw organic structures the way we do with just the lines. So here we're going to start with methanol. Here's our alcohol group and it's only got one carbon, so methanol, all right? We'll draw the Lewis dot structure first, and we get something that looks like this. I will be drawing the lone pairs around oxygen because it's considered a center atom. All right, we have to think about the geometry around it, so we need to take into account the lone pairs. The way that you do something like this is you need to pick your centers. How many centers do we have in this one? The carbon is one and the oxygen is the other. And we have to pick the geometry about those centers. So if we look at the carbon, we have 1, 2, 3, 4 bonding groups. No lone pairs. 4 bonding groups, no lone pairs. That's a tetrahedral. And so we'll draw that tetrahedral like so. One important thing to keep in mind as you start drawing is to keep all the members of a chain, regardless if they're oxygen or carbon, in the plane of the board. It's going to make your life a lot easier, all right? So we have our tetrahedral shape for carbon. Then if we look at oxygen, oxygen has 2 bonding groups and 2 lone pairs. That's a bent geometry. And so we've already established where one of those bonds is in the plane of the board here for oxygen. So I'm going to fill in the lone pairs here on the bottom, and we get our bent geometry here. Now mind you, this can be drawn in an infinite number of ways depending on how you want to look at it. Another way to draw this would be, again, to have the H going up in the plane of the board, the oxygen here, hydrogen, hydrogen, but now I'll put my lone pairs here and have the hydrogen coming back. Both of these structures are equal, all right? You'll see me draw it like this most of the time because it's just easier to go horizontal than start twisting and turning with hydrogen. Here we have ethanol, all right? Ethanol, CH3CH2OH, our alcohol group for ol, and then Eth because we have 2 carbons. So if we draw the Lewis dot structure first, we get something that looks like this. Okay? Let's start with the carbon on the left. We have 4 bonding groups and no lone pairs, thus it is a tetrahedral, and it'll look something like this. There's our tetrahedral about that carbon. The next carbon has 4 bonding groups and no lone pairs, therefore that one is tetrahedral as well. So I'm going to have the O coming off here, then our H's here. If you'll notice, in all my drawings, the wedges and the dashes are next to each other. If you put them on opposite sides of the atom, it's not an accurate three-dimensional representation of what we are looking for. So we have this guy right here. Finally, we have oxygen. 2 lone pairs, 2 bonding groups. We call that geometry bent. It looks something like this. Hopefully you're seeing how the organic drawing plays a role. Remember the little sticks that we use? Because if we were to draw this, we'd have a carbon here, a carbon here, and then up to an OH group. This idea that we keep zigzagging back and forth is how we get to organic drawing. Finally, and we'll show you organic drawing here, we have C6H4, then OH2. The 2's in parentheses, so there are 2 separate OH groups. And there's actually 3 different ways to draw this. I'm going to draw one way in particular. So if we look at this, our C6, we know that we're talking about a 6-membered carbon ring. So we have, this is going to take a moment for me to draw. We have something that looks like this. But we know there are double bonds alternating in here. We have something that looks like that, right? Now, we have hydrogens coming off of 4 of the carbons. And we have OH groups coming off the other 2 carbons. So we have something that looks like this. Let's go through geometry. Here, these 6 carbons all have the same geometry because they all have the same bonding. We have this carbon, double bond, single bond, single bond, 3 electron groups, no lone pairs, it's trigonal planar. Trigonal planar, etc., through the whole thing, all right? So it sits flat, and we've done a pretty good job representing it in 3-dimensional space already. But if we go down to the oxygen, I'm just gonna erase this so we don't have to draw the whole structure again. We have 2 bonding groups and 2 lone pairs. That means that geometry should be bent. So if we erase this, we get our bent geometry down here, and the OH group up at the top is going to have the same. So if we erase this, we get our OH group there. There we go. So we have a bent geometry and bent geometry. Now if I were to draw this with organic drawing, it's going to be a little bit easier. We draw our hexagon, put our double bonds in, and just put our OH groups up at the top. Hopefully you can see what's going on here, all right? So this is how we draw organic structures using VSEPR, all right? Now, there are millions of organic compounds. So if you're curious, just look up some organic compounds, don't make them too big, and you can practice on your own. But these are 3 ones that I've chosen because they have different features. Here you can see what happens as a chain lengthens. Here we're looking at our ring structures.